Hello everyone, I Smita Selat welcome you all to the Swayam online course on artificial intelligence using Prolog. In this series of lectures, we will explore learning component of artificial intelligence with explicit focus on machine learning theory. In the next 5 lectures, we will understand the concept of machine learning, the supervised machine learning algorithms, and these supervised machine learning algorithms will cover 2 classes, the regression and the classification. Then the next we will cover the different types of classification techniques like support vector machine, logistic regressions and decision trees. In continuation, we also learn how to evaluate the performance of these learning techniques. And finally, we will also discuss about the unsupervised learning and its classes of algorithm. These will be the focus of upcoming lectures. So now, to start with, let us try to understand what machine learning is all about, how it has evolved over the period of time and why it is getting so popular, what are its applications and what are different types of machine learning algorithms. So, what is machine learning? Machine learning is a branch of artificial intelligence which explores techniques through which computer tries to learn a concept, and this is exactly like the way we humans try to learn. Actually, machine learning algorithms, they capture the cognitive skills of human behavior. This behavior is simulated through these algorithms. Now, talking about the learning, it is not new in the field of AI. Its existence is observed since 1916s. In those days, efforts were put to make system intelligent by embedding learning through a handcrafted rules. For example, if you talk about Mycin expert system, nearly 500 if then else rules were handcrafted and then they were used to predict the disease using the blood cell properties. So, rules were written for the blood cells and the diagnosis of the disease. Lot of expertise, knowledge and the effort was required to develop such system. Over the period of time, the technological revolution in the field of communication has given internet facility to majority of the population of the world. Individuals can access internet through their smartphones and devices. This leads to large volume of user generated content on the servers. This volume of data is of great significance to business houses, production systems, medical, healthcare, etc. These UGC generated data is used by the machine learning concepts to find out the trends, patterns and predict the results. So, finally, what we find that machine learning has shifted from a conventional rule based system to a data driven approach. When computer systems started learning from such a large volume of data, the term machine learning was coined. Data is used to make system learn trends, patterns and give predictions for various kind of problem. For higher level of complex tasks like understanding an image or understanding a language, deep learning techniques were introduced. So, we can now visualize AI as one broad single umbrella under which learning is achieved through machine learning concepts and higher level complex problems are solved more sophisticated problems through deep learning techniques. ML is a significant concept under AI and deep learning techniques are complex ML algorithms. This containment relationship is exactly depicted in the figure. So, coming to the point, what is the basic learning? One can understand this as an ability to improve one's behavior based on the experience. This we all know that when we perform a complex task, it becomes easy to solve if we have already solved similar problems multiple times in the past. Hence, our experience play a very important role in problem solving process. Similarly, in ML, systems are built which can automatically improve from experience, which is nothing but the data. Hence, the basic machine learning algorithm tries to learn from data. Models are built using this data, and once these models are ready, they are used for predictions and decision makings. That was the very fundamental concepts of learning and machine learning. Let us now look into the definitions which has been given by popular scientists, the definition of machine learning. Arthur Samuel in 1959 defined ML as a field of study that gives computers the ability to learn without writing explicit long sequence of codes. Means programming was done without writing codes. Instead, a large collection of data was sufficient enough to build a ML model. Another scientist, Tom Michel, in 1998, he posed the learning problem as a computer program is said to learn with the experience E with respect to the some given task T and some performance measure P. If its performance on the task T as measured by P improves with the experience E. This is exactly like the way we humans learn. Let us try to understand this concept with the help of examples. We all deal with our emails in day-to-day process. Some of the mails are valid and some of the mails are not valid. The mails which are not valid is termed as spam. Not all the mails received in our mailboxes are the desired mails. We often mark some mails in our mailboxes as spam. This pattern of marking or filtration is observed by the mail software and it learns or understands whether the mail is a spam or not. So, what is the task T, experience E and the performance P in this example? Classifying emails as a spam or not spam becomes the task. Marking email as spam or not defines the experience, and performance is obtained by calculating the number of emails correctly classified as spam or not spam. So, now next question comes, over the period of years, how this ML has evolved. So, now let us talk about how the machine learning evolved. It all started around 1950 when Samuel started exploring learning through game playing. Game playing was very famous, was very challenging task at that time. So, he first wrote a program that can play checkers and it took him 6 years to develop such system, and it was developed in IBM. Another example is IBM Deep Blue program, which created a history by defeating the world champion Garry Kasparov. Later in 1960, neural networks were built to simulate the cognitive skills, but its application was limited due to the behavior of the perceptron at that time. Coming to 1970s, lot of efforts were built in making knowledge representation tools using symbols and graphs. Knowledge representation structures and reasoning mechanisms were built, expert systems were introduced like Mycin and Dendril. Work on natural language processing also started, and a very first NLP based system, ELIZA, was introduced as a computer based assistant. Although it was not a pure NLP program, but its results were quite satisfactory. In 1980, more focus on the learning algorithms like decision trees, rule based learning was seen. A complex planning system for a problem solving process was introduced so that robots can follow that algorithm to solve the problems like arranging blocks in a particular pattern. This talks about the history or evolution of machine learning. With the availability of huge volume of data, machine learning started whispering in early 1990s. Data mining concept used statistical properties of data to interpret and mine the association amongst data. Agent based learning system also started seeing in this era. Probability theory was used to build Bayes network for predictions, which could also answer some of the questions from uncertain domain. Later in 2000 and late 90s, ensemble techniques and reinforcement techniques also evolved. Techniques to learn text and images started showing significance in early 2000, as image and text, as we can see, are nowadays most popular and frequently used data in the internet. Neural network and deep learning architectures are nowadays commonly used to solve much complex tasks. Large volume of data generated by the users is also stored in cloud-based platforms, thereby reducing the requirement of huge hardware by individual organizations. Big data, data analytics, all these techniques are helping to organize large volume of data, and they are also helping in extracting the meaningful context from it. So, how this machine learning concept is different from our conventional programming? As it is shown in the figure, conventional system was fed with data and the program, and the system generated the output or the result. On the contrary, ML algorithms are fed with data and output, and it generated the learning program. This was the basic difference between the two theories. Huge volume of data in a form of user generated content is generated by users. Most of the users in the world, they have smartphones and internet facility. Availability of net facilities and these smart devices to majority of the population across the globe has changed the way the business are working nowadays. E-commerce platform has grown tremendously due to these two factors. Customer reviews, customer likes, the comments, etc. They provide very meaningful feedbacks to business houses. This data is analyzed to study consumer behavior and their interest, and ML algorithms are now taking such data as an input, and these models can perform the task of prediction, trend analysis, classification and pattern recognition. So, in the next slide, let us try to understand how a machine learning technique works. Let us have a look on the diagram given. As we can see, data is fed into the algorithm and the model is trained and model is built based on the input data. And when new data is fed to the trained model, output is obtained and model performance is evaluated on the generated output. Once the model is built, it can be used to perform the task of prediction or classification. Looking into the major components of machine learning techniques, they are data, features and the model itself. As discussed, data is a collection of recorded experiments, values from the various sensors, reviews or the feedback specific to the problem. Data represents various features which are essential for solving the given task. Some of the features are very much significant, but some are not. For example, while predicting a price of a house, the area and the location of the house is more important than the garden space available. Model is representation of a phenomena that a ML algorithm learns from input data. So, now we can describe the complete process of machine learning algorithm. It majorly consists of 5 major steps. 1. The data collection. 2. Data pre-processing. 3. Training the model. 4. Testing the model. And 5. Evaluating, and finally tuning some of the parameters for better results. Data collected from different sources like social media, from organizations or the companies, or recorded data from the sensors are accumulated either in Excel, .csv or text files. Data may be numerical or it may be categorical, but it is divided into training and testing in 80-20 ratio or 70-30 ratio. In data preparation phase, data is cleaned, meaning data is normalized, data is scaled, garbage values are removed and some normalization is performed. Categorical data is converted into the numerical form. Once the data is pre-processed, 80% of the data is fed into the system to train the model. Trained model is then fed with 20% of the test data to see how our model performs, which has been trained. Performance of the system is then analyzed using evaluation matrix. Evaluation matrix are different for different kind of classification algorithm. If the performance of the model is not satisfactory, parameters are further tuned to improve the overall accuracy of the system. Let us now look into the different types of the machine learning algorithm. Here we can classify machine learning algorithm as supervised, unsupervised, semi-supervised and reinforcement algorithm. Supervised machine learning algorithm, as the name suggests, they generally use labeled data for training the model. For example, if we have input and output training data, it contains the input features like x1, x2, x3 along with the labeled output value yi. So, what does labeled data means? Actually, for a given set of x value, output y should be known, so that system learns the association between the input values and the output values. Let us take an example. Let us say if we are developing a machine learning system for automatically classifying of fruits, and we have a mixture of fruits like for example apple, orange or banana. System learn the features of these fruits as the shape, color, taste, number of seeds, and the output is the name of the fruit, which is either apple, banana or orange. The data is used to train the model and then it is evaluated using test data. Test data also contain input and output, but we only feed input data to the system, and then the trained model gives us the predicted output. This predicted output is compared with the actual output and results are compared to find the accuracy of trained model. So, main objective of supervised machine learning algorithm is to find a function which maps input values to the output values. Larger the training data, better will be the learning of the model. SML, that is a supervised machine learning algorithm task, is further divided as the regression task and the classification task. Next, we will take a brief look on the unsupervised machine learning algorithm. Unlike supervised, unsupervised machine learning algorithm do not require any label output. So, how does it work? As the name suggests, the unlabeled data in the form of input features are given to the system. The main objective of these unsupervised algorithm is to find similar patterns that exist amongst the data set and group them into the clusters. One very simple methodology to check this similarity is to find the distance between the data, and that distance is calculated using distance metric. Let us take an example of unsupervised machine learning algorithm. For example, e-commerce website may be interested in type of the visitor who are purchasing their products. The gender, age, profession, geographical location, weather condition, etc. may influence the choice of the customer. People with similar interest may purchase similar products. So, clustering users on certain input parameters may identify them as people with similar interest, and that is what unsupervised machine learning algorithm aims at. Another way to introduce learning is through an agent based learning, where agents learn through the systems of award and punishment. This is exactly like we teach a small child or students in school. For every correct action, agent is rewarded, and for every wrong steps, punishment is given. A policy is defined what action an agent should choose in a given situation. This is a brief about various algorithms in machine learning. Now, let us come to the application side. Machine learning is used in many real world scenarios like medicine, agriculture, entertainment, etc. In the field of medicine, if you want to build a machine learning model to predict the disease of a patient, then the input data should be like symptoms of the patient, the test results, the lab measurements, etc. And the output is one of the possible diseases. Data collection of the patient's records from hospital or available data set from the websites. Now, model is built to learn features for various diseases and predict correctly when test data is given. The complete process and the complete machine learning algorithm for the diagnosis of the disease is depicted in the given figure. This application of prediction will fall in the supervised machine learning category, as we have input as well as the labeled output. Here we can see that data after collection is pre-processed for null values, it is normalized. Input features, for example symptoms and etc., and output feature, which is a disease, is given to the model in training phase. Once the model is ready, the input feature values of test data is fed, and then this trained model predicts the output. Let us talk about the another application of machine learning, which is very popular and common nowadays, the computer vision. Here, input is not the data but an image. Whenever an image is given to the system, machine learning algorithms are used to identify objects which are present in that image. Here, input is not the categorical data, but input is colored image and our red, blue and green pigmentation values of pixels becomes the feature set. Model is trained with these pixels, and then the ML algorithm tries to recognize objects within the image using the techniques. Another example is converting handwritten digits into the characters. It is also one of the examples of machine learning algorithm. Another application of reinforcement learning is robot control, where robot, which is actually an agent, is trained to play a game. It uses the principles of award and punishment. Theory is exactly the same which is used for training a child. These algorithms, whether supervised, unsupervised or reinforcement algorithm, they focus on capturing cognitive behavior of humans. Another application of machine learning is natural language processing. It is nowadays a very popular and a very important applications. Here the system is trained to learn the natural language. Natural language means the language which is spoken by us, like English, Hindi, Bengali, Punjabi, etc. What is the challenge in NLP applications? Actually, language by itself is very much ambiguous. It consists of lot of hidden ambiguities, whether it's a syntax, semantics or any other part of that natural language. Developing a system which can understand the complexity of the language is a challenging task. So, here in NLP application, input is given in the form of speech or text. Some of the applications which are very popular under this domain are speech generation, like we all have seen our Gmail. Whenever we write in a Gmail, for completing a sentence, the word is being prompted in the Gmail. Another application which is related to NLP is a translation system, which translates a source language to the target language. For example, English to Hindi, English to French, French to English and so on. Another very important and popular application in NLP is sentiment classification. We all know when we speak a language or when we write a review, sentiments are attached or tagged within the sentence. For example, if we watch a movie and we write a review, we write with a positive note or we write with some negative note. So, whenever we write, the sentiment values are attached in the reviews. So, sentiment classification is a very vital and important application nowadays used in the industry to gather the reviews and find out what users are thinking about our product or our institution. So, as we can say, the application of machine learning models are too many and unlimited. We cannot cover all the applications in one lecture. Financial applications like predicting the stock market or predicting the profit of the banks for the next financial year are also important set of applications or important areas where machine learning algorithms are implemented. So, machine learning are also nowadays used in the cybersecurity to identify the threats and the fraud which are associated during the fund transaction, money transaction, use of ATM, etc. Everywhere we find the applications are AI based and the backbone of AI is machine learning. So, here we find that machine learning is now applicable to day activities like in banks, in cybersecurity, in education sector, even in the film and the entertainment sector. Everywhere we find artificial intelligence along with machine learning is paving its way towards the problem solving process. The approach towards solving a problem is now data driven, and whenever we use a bulk of data to solve the problem, ML comes into the picture. So, this is a very important and very convincing field for computer science students and the professionals. So, in this lecture, we studied the basics of machine learning, how it evolved over the period of time, its working methodology, the different types of machine learning algorithms like supervised, unsupervised and reinforcement algorithm. We have also given a brief on the certain applications which are using machine learning concepts. I hope you enjoyed this lecture. In the next lecture, we will study some of the supervised machine learning techniques. Thank you.